Welcome you all to this class. Today we are going to discuss regarding the A-level chemistry, Cambridge chemistry. We will we have already discussed regarding the up to 10th lecture, and most of you have already completed your lectures, and few of them have given sit for already sit for exam, and most of the students have done well. So thank you all, those who have already completed the exam. Students who are not completed the exams are advised to sit for the exams, that is a mock test that has been given to your page, and all students are advised to stay connected and to follow their own page. So today we are going to discuss from the next portion of physical chemistry, Cambridge A-level physical chemistry. So before going to that, let me open our digital board. This is our digital board, and now we are going to start our classes. Okay, so this is the website. You know that the everything is there. So just come to your website by logging to your dashboard, and after coming into the dashboard you will get this types of page, and then after coming here you can see here the physical chemistry portion, and then just click on the like note and video lectures, and then we are discussing regarding the lecture 10s. I hope it will help you to get the idea. So before going to do that, we are in need to open the uh, note. Okay, let me introduce first this one. This one. You can go here. No, lecture note. This one. Okay. Lecture 10 is also on this note. So we are going to the cover the next portions of the note. The questions has already been discussed here. You are advised to complete meticulously for getting the maximum output. I hope it will help you to get the clear conceptions regarding the questions and the subject matter. So today we are going to discuss regarding the new issues. Uh, Here you can see at your note, lecture number 9, you can see here the answer has been given here. Okay, answer has been given here. So just try to understand and find out the process how the answer has been given, and the correct answer also been given there. So now today, explain electronic configuration. So electronic, in case of electronic configuration for A-level chemistry, we should use orbital concept, not the circular orbit. Okay, we should use orbital concept, and orbit, in case of orbital concept, we should use SPDF, right? What is the orbital? Orbital, we know the three-dimensional space around the nucleus is the orbital. We have discussed earlier, but today our concept is that today our discussion is that only for the electronic configuration. So what is the electronic configuration? What do you mean by electronic configuration? Electronic configuration means to distribution the electron around the nucleus. That means in within the orbital, not orbital. So in case of electronic configuration, you should have to understand the electronic distributions level or model of or in all the orbitals. So in our consideration, we should majorly focus on sp and d orbital, sp and d orbital. So s orbital contains only two electron. We know that s orbital contains only how many electron? Two electrons. How many electron? Two electrons. Okay. S orbital contains only two electron, right? Two electrons. So we are going here. S orbital, s orbital, s orbital, s orbital contains only two electron. E orbital contains only 6 electron, D orbital contains only 10 electron, and F orbital contains 14 electron. So our major focus for up to A level, up to D orbital, for A level up to D orbital, right? So when you will distribute electron should be distributed, how the electron will be distributed, and in which process electron will be distributed within the orbitals. These are governed by the few rules, and all the rules have to apply during electronic configuration. So in this regard, we are in upbound principle, and then Pauli exclusion principle and Hund's rule, right? These are the basic rules which are which are applicable for considering the electronic configuration. So a question will be asked to you, um uh, find out the write down the electronic configuration, or find out the right electronic configuration. Okay. So what is upbound principle? Electron fills orbitals starting from the lowest energy level to higher energy level. This is upbound principle. Lowest energy level to higher energy level. So we will try to understand the concept, right? So let's go to start our mm, mm, digital board. This one. Okay, I'm just getting it here, and so that we can uh, this one. Okay, we're coming here. So this one. Okay, I'm getting it. So this one. Let's start. Upbound principle. You can say upbound principle, right? Up AUF BAU, Abba principle. What is Abba principle? Abba principle is telling you that electrons fields orbitals starting from the lowest energy level to highest energy level. So we have to understand what is lowest energy level and what is highest energy level. Okay. So what is lowest and lowest energy level? This is 1s, 1s. This is the lowest energy level. This is 2s, 2s, 2p. This is the comparatively higher. Then 3s, 3p, 4s, 3d. This is the much more higher energy level. So in that case, you should understand that if you have two electrons, then it will go this one. If you have three electrons, then it will cover this one, and then this one, and then this one, this way, right? And then this way. So what I'm telling you, I'm focusing on the syllabus so that you can understand. Uh, First electron will in into the 1s orbital, and then the second electron 2s and p orbital, and third electron will go next electron will go to 3s, 3p, 3d. Before going to 3d, it will enter into the 4s because the energy level is lower. So upbound principle is telling you that the electron, you cannot distribute electron to directly 2s orbital, right? Why? Because upbound principle is telling you the energy electron will enter into the lowest energy level to higher energy level. So I hope you have understand this principle. Then we are going to the next one. Let's go to the previous slide. This one, this one, this one, this one. Okay, you can see here. So going back, this one. Okay. So we have learned the upbound principle among this should be applied to all the electronic configurations so that you can easily write down the electronic configuration. In our early classes, we have discussed regarding the balancing process, right? I also tell you the tricky method of balancing process so that you can easily balance any equation. Okay. Uh, so now we are going to the next portion. This one, this one, above principle. Okay. Then what is the exclusion principle? No two electrons in an atom can have the same set of four or quantum numbers. Just you should memorize this one. Quantum number, there are 4 or 5 quantum numbers. So we are not discussing regarding the quantum number. Just note down and keep in mind this one. No two electrons in an atom can have the same set of four or quantum numbers. Okay, just remind it. We will discuss if the syllabus required, and if we later, not our discussion right now. And then Hund's rule, orbital of equal energy are filled with one electron each before pairing. It means that orbitals of equal energy are filled with one electron each before pairing. Okay, so let's try to understand what is telling this one. Think that sodium has 11 electron, right? So what will be the electronic configuration? You cannot write this one. Same energy level. Firstly, try to understand what is same energy level. Same energy level means one is this is there is no other orbital. So this is only one. So there is no problem there. When you go to 2s 2p, right? uh, electron is not going to enter into these 2s and 2p. You know that s orbital contains two electron, right? So two electrons, same energy, it will be filled by two electron. Then px, py, and pz. So we have here is two, then nine electron left. So nine electron will be distributed in this way. 2s2. This is the same energy level, and 2p, 2y among 2z. This will how it will be distributed. So this will be one, firstly, not two, then p1, then py1 and p2. Then the one is left. So this will go to this one. So uh, 2 plus 2, 4, 6, 7, 8, 8, 9, 10, 11. So in this way, it will be filled up. It will not be distributed like this. And the 1 is 2, 1 is 2 is 2, 2p x2, and 2py2, and pz1. This is not the electron will be distributed gradually and before binding any pairs. So pair will be formed later, but distributed in a single way. One electron will go to each and every orbital, and is there any left electron, then it will go to the next orbital, right? I hope you have understand how the what the Hund's rules is distributing. It is also it has also another name, which is known as Hund's rules of maximum multiplicity, right? Hund's rules of maximum multiplicity, or Hund's rule. So in our as per our syllabus, the above principle and Hund's rules are mostly important for the final exam. So you should focus on this one for learning the electronic configuration. N- Now cell. What is cell? Cell indicated by the principal quantum number. Principal quantum number is denoted by n. Principal quantum number is denoted by n. So what is principal quantum number? This one. First order, second, n equal to 1, n equal to 2, n equal to 3. This way, right? And subcell, these are the subcell means orbital. So subcell have another name, which is known as orbital, right? Number of electron, superscript after the subcell letter. Okay. So number of electrons, it means that one orbital will contain only two electron, and then s orbital, and in case of p orbital it will contain six electron, and in case of d orbital it will contain 10 electron. So in this way, electron will be distributed. So you can see here, there is an example of sodium atom, and the electronic configuration has been given here, right? The visual presentation using box and arrow. Okay, this one, noble gas configuration for elements beyond argon. You can use the noble gas notation to sort the configuration. For example, potassium can be written as ARS1, but that means noble gas configuration. So each and every element from argon, beyond argon, we can also write as a noble gas configuration. So it will be right in this way. Okay, but it will be better. You should practice in details. It will help you to get the clear conception and to understand properly. So now the above principle, here is an example of above principle. You can see here, first electron go to the second, or first 1s orbital, then 2s orbital, 2p, then 3s, 3p, 4s. You can see here 4s is before 3d, right? Here you can just focus here, this one 4s is before 3d. Why? Because 4s require the less energy. As per above principle, electron will be distributed from the lower energy level to higher energy level. That's why electron will go to the forest. Then after completing the forest, if there is any electron left, that will go to the 3D. Then 4p, 5s, then 4d. Before going to 4d, it will enter into the 5s, and then 5p, and then 6s, and then 4d, 4d before 5d, it will go to the 4f. So it is a very complex and complicated electronic configuration. But if you learn up to this one 4D, up to 4D, it will cover your syllabus fully. So we will focus the electronic configuration of the elements, which goes to the up to 4D. So this is our main objective, to learn the electronic configuration. So I hope you understand regarding the electronic configuration. Now, the electronic configuration that you should practice. What are the element? Now, I'm just telling you the name of the element for which you will should consider the electronic configuration in your own practice, for your practice, and these are the most important electronic configurations for the final exam. What is that? The element name is sodium, then sulfur, then phosphorus, then carbon, then nitrogen, then chlorine, then fluorine, then uh, mm, argon, krypton, and then okay, this one, oxygen. Okay, so these are the elements. These are the element for which we have to practice the electronic configuration, including this molecule. You can also practice cobalt, nickel, and mercury. Cobalt, nickel, and mercury, and copper, and iron. If you learn the electronic configuration of these elements, then it will cover your full syllabus, and all the questions you will get the cover in the final exam. So practice more and more. From this lecture, you have understand try how to write the electronic configuration. So we will take now one or two exam, right? So already you have discussed regarding the sodium electronic configuration. Now we learn carbon 6. So what will be the electronic configuration? 1s2, 2s1, 2p1, x1, 2py1, 2pz1, right? Then how many? 4, 2, 3, 4, 5. So you have one electron left. This one will go to this one, not p, not py, not pz, not px, right? So you will have to write in this way. 4, 5, 6, right? Sorry, this one, not this one. This will be single. This will be single, right? 2, 3, 4, 5, 6. Okay, this one. So in case of nitrogen 7, you should practice in this way. 1s2, 2s1, 2px1, 2py1, 2pz1, right? So 2, 3, 4, 5, 6, and that one is 7. So 7 is covered. In this way, we should practice. Now, if you have any questions, or if you face any problem, or if you still do not understand how to write the electronic configuration, that means that comments in the uh, your sections, or inbox me, so that I can clear your concept. So thank you so much. This is the lecture number 11, and we are closing the 11, and wait for the next one. And in the meantime, you should cover the lecture number 11. I hope you understand.